This video is about interpreting graphs and plotting points on the coordinate plane and identifying their quadrants. So a coordinate plane has 4 quadrants. Each quadrant represents a different type of coordinate that is distinct to its quadrant. So when we number our quadrants, we're going to number them counterclockwise. So we have 1, 2, 3, and 4. We're going to use Roman numerals when we label our quadrant. So in quadrant 1, all of our x, y coordinates are going to be positive numbers. In quadrant 2, the x coordinate will be negative, but the y will stay positive. In quadrant 3, both of our coordinates will be negative, and in quadrant 4, our x will be positive, but our y will be negative. So let's go back and look at our coordinate plane. So with the coordinate plane, the vertical axis of the coordinate plane is going to be our y-axis, and the horizontal axis is going to be the x-axis. So see, by the vertical we have y here, and by the horizontal we have x. So points are always written in the form x comma y. The x coordinate shows us how far we are going to go to the right or to the left of 0, 0, also known as the origin. So 0, 0 always starts in that middle of the graph. And then for the y coordinate, it's going to tell us how far we're going to go up or down from the 0 quadrant. Then wherever those two grid lines meet, that's where we're going to put our point. So here we have points on the graph already, so we're going to identify their point and what quadrant they're in. So the first point is A. So A is right here. It lines up with 6 on the x-axis and 2 on the y-axis. So our coordinate would be 6, 2. Remember, it's always x and then y. So this is in the first quadrant. And that makes sense because both of our points are positive. B lines up with 2 on the x and 9 with the y, so our coordinate would be 2, 9. This is also in the first quadrant since both points are positive. C is over here in the second quadrant, and it lines up with negative 7 on the x-axis and 3 on the y-axis. So we would have negative 7, 3 as the coordinate, and this is in our second quadrant. Remember, they are numbered counterclockwise. D is right here above the origin, so it didn't go anywhere left or right, so the x-coordinate is going to stay as a 0. It did go up 1 though, so our y quadrant's 1. So we have 0, 1. This time it's not on a quadrant because it's on that axis that's vertical. So this time we're going to say that it's on the y-axis. E is over here, and it lines up with negative 6 on the x-axis and negative 5 on the y-axis. And because both of those are negative, we know we're in the third quadrant. Our last point, F, lines up with 8 on the x-axis and negative 2 on the y-axis. So our point is 8, negative 2. And this is in the fourth quadrant. So now let's plot some points on our graph. So the first point for G is negative 2, 6. So I'm going to go to negative 2 on the x-axis. See where it lines up with negative 6 on the y-axis. I'm going to put a dot and label that point G. H is 0, 9. So I'm going to go to the origin. I'm not going to go left or right anywhere because it's 0, and we're going to go up to 9. That is H. I is at negative 5, 0. So we're going to go over negative 5. We're not going to go up or down at all. That is I. And then our last point, J, is 4, negative 9. So we're going to go to 4, see where it lines up with negative 9. Then we're going to place our dot and label that J. So let's look at interpreting graphs now. So the mayor of a town really wants a manufacturing plant to come into town. The mayor claims that the population of the town is increasing rapidly and that new jobs the plant will provide is necessary for the increasing population. However, an environmental group is opposed to the manufacturing plant. They have a history of massive pollution. The environmental group claims that the town's population isn't increasing by that much and the extra jobs are not needed. The two sides cannot agree, so an independent investigator is brought in to give their opinion. So the three sides are the mayor's office, the environmental group, and the independent investigator. So all of these graphs show the data represented. We have the independent group here, the city council, and the environmental group. Now, if we look at the graphs, notice that all of the the x-axis and y-axis labels are the same. We have years on the x and populations on the y. They're just differently represented based on the scale. So how are these graphs different? Well, if we look at the y-axis, they all have different scales. This is going up by 2s, this is going up by 1s, and this is going up by 4s. So how are they different? The three graphs have different y-axis scales because they're all counting up by different numbers. So how are they the same? Well, if we look at the same, all of the x-axis are the same. We have the same number of years. Also, the points are the same. So if we look at this point, 2,000 and then 10,000, 100,000 for the population, we notice they're all the same point. They're just shown differently on the graph. So what are the same? Is the three graphs have the same x scale and show the same data points. So identify the vertical scale used. So when we're looking at the vertical scale, we want to know what each line is going up by. So if these are going up and skipping a line each time, this is 0 in the corner here. So the number between 0 and 4 would be 2. So these are going up by 2s for graph A. If we look here for graph B, this is 0, and the number between 0 and 2 would be 1. Here again, this is 0, and the number between 0 and 8 for graph C would be 4. So the scale for graph A is 2s, the scale for graph B is 1s, and the scale for graph C is by 4s. So these graphs show the data can be represented in different ways. A small alteration to the graph's design and scale can change its appearance and the message it conveys, even if the data stays the same. So let's look at another example here. So we have use the information from graph A and graph B to answer the following questions. We have graph A and graph B. We see years on the x-axis for both, and we see annual tuition on the y-axis for both. So the graphs look different. Do they represent the same data? If so, how do we know? So we can look at some different data points here. So at, let's say 2005, this is between 40 and 50. And in 2005, on the other graph, it's at 44. So we'd say that's about the same point. If we look at the end, 2010, they're both just very close to the 50,000, but not quite there yet. So it looks like from looking at our data points that they have the same data points, so they're the same. So they represent the same data because they have the same data points and labels. So give an example or explain a person who might use graph A. So if we look at graph A, we see that it's kind of flat and there's a little rise in it, but not much. So somebody that might use this to show that the tuition isn't increasing by much would be a college, because they want to show that, look, our cost is staying the same from year to year. So graph A might be, somebody might be from a college or university. So let's look at the scales. What are the horizontal scales? So the horizontal is the x-axis. So notice that each year is going up by 1 because we have 2005, 2006, 2007 on graph A. Same thing on graph B. So our horizontal is going up by 1. Now the y-axis is different for both. So here, from 0 to 10,000, it's climbing by 10,000s. And in graph B, we went from 44,000 to 45,000, so it only went up by 1,000.